All right, we are continuing on with Unit 8, and we're going to start writing the quadratic equations, starting with solutions. So instead of starting with the graph and writing the solutions, we're going to go backwards. Let's look at the graph, and the solutions of the function are going to be x equals -3 and x equals +5. We're going to set each of those equal to 0 by adding the opposite. So I'm going to have x plus 3 equals 0, x minus 5 equals 0. So factored form is going to be x plus 3 times x minus 5. And then I'm going to multiply those together to get my function in standard form. And I will draw my box. And I have x plus 3. And I have x minus 5, and I'm going to multiply. X times x is x squared. X times 3 is 3x. -5 times x is -5x. And -5 times 3 is -15. So my standard form is going to end up being y equals x squared. I'm adding together my 2 with the same, so I have 3x minus 5y. So I have minus 2x minus 15. So here's my standard form, and that's what we're going to be doing on this worksheet. So let's keep practicing. When I have my roots, if that's what x is equal to, so I have x equals -6, x equals 4. I set them both equal to 0. I have x plus 6 equals 0, x minus 4 equals 0. I'm going to multiply my factors together. I'm going to split apart my first one. I'm going to multiply it times my second one. And I'm going to distribute x squared minus 4x plus 6x minus 24. I'm going to combine these terms, x squared plus 2x minus 24. And that's my answer. Pretty straightforward. And we actually did a couple of these on one of our factoring, no, not our factoring worksheets, on our solving quadratic equations worksheet. So this should look pretty straightforward. So for number 2, x equals -10 or x equals -5. Those are my two x-intercepts. Let's set them equal to 0. X plus 10 equals 0. X plus 5 equals 0. I'm going to take my two factors and multiply them together. I'll make my box over here. I think I have room. So I have x plus 10 and x plus 5. X times x is x squared. X times 10 is 10x. 5 times x is 5x. 5 times 10 is 50. I'm going to add those two together, and so I end up with x squared plus 15x plus 50, and that's my y equals. So you should notice that my factors are the same as my solutions, but just with the opposite sign. So hopefully that makes sense and you'll be able to cut out a couple steps. Okay, number 3. If x is only equal to -3, then I know that x plus 3 equals 0. If it has one solution, that means that the other solution is still -3. So I really have x plus 3 times x plus 3. So I'm going to multiply x plus 3 times x plus 3, and I end up with x squared plus 6x plus 9, which is a perfect square trinomial, and that's equal to y. One solution means that both my factors are the same. Okay, number 4, I've got two solutions. I've got x equals +11/2 and x equals -11/2. Set those equal to 0, and they're going to switch. So I have x. Actually, before I set them equal to 0, I'm going to multiply times 2 on both sides. So I end up with 2x equals 11. 2x equals negative 11. 2x minus 11 equals 0. 2x plus 11 equals 0. So my factors are 2x minus 11 times 2x plus 11. So I'm going to end up with 4x squared minus 121. Anytime I have the same numbers and one's minus and one's plus, my b term is going to equal 0. And so I have 2x squared is 4x, 2x squared is 4x squared, and 11 squared is 121. And anytime my solutions are fractions, I'm going to have a value in front of my x. Okay, number 5, same thing. They've just already set it equal to 0. So I'm going to set those equal, no, let me say that again. They already wrote them as what x is equal to. And so all we need to do is set it equal to 0. X minus 6 equals 0. X plus 7 equals 0. So I'm multiplying x minus 6 times x plus 7. I will draw a box. X minus 6, x plus 7, x squared minus 6x plus 7x minus 42. So I add these together and I have x squared plus x minus 42. Okay, number 6, I have fractions again. I have x equals 1/3, x equals negative 3 over 5. The first thing I'm going to do is I'm going to multiply times my denominator. And this one I'm going to multiply times 5. So I'm going to have 3x equals 1. And I'm going to have 5x equals negative 3. Set them equal to 0. 3x minus 1 equals 0. 5x plus 3 equals 0. There's my two terms. So I have 3x minus 1 times 5x plus 3. 3x minus 1, 5x plus 3 times 5x plus 3. Distribute, and I have 15x squared plus 9x minus 5x minus 3. Combine my terms, 15x squared plus 4x minus 3. And then number 7, we have the roots and their fractions again. So we're going to end up with fractions for our, we're going to end up with our coefficient with x being not 1. So x equals negative 2 over 7, x equals negative 5 over 9. I'm going to multiply both sides by 7 in this case. 7x equals negative 2. I'm going to multiply my other one times 9. So I'm going to have 9x equals negative 5. When I set it equal to 0, I have 7x plus 2 equals 0. 9x plus 5 equals 0. Multiply my 7x plus 2 times my 9x plus 5. And I end up with 63x squared plus 18 plus 35 equals 53x plus 10. Okay, hopefully that makes sense. We've done it before. I thought this would be an easy lesson for y'all to watch over the weekend. So here's what happens. Somewhere around problem number 8, you're paying attention and you go, ooh, she did one of those things. If you come up to me on Monday and say, good notes, Miss Nagel Perkins. then I'm going to have a surprise for you. And you have to say it before you walk in the door, because once you walk in the door, if you say it, it's too late. And don't tell everybody, because the whole point would be you get a treat and they don't, because y'all watch the video. It's your reward. So make sure you just, shh, keep it a secret. All right, so you have a couple of ways you could do this. You could, well, first of all, I'm going to set these all equal to 0, right? So I'm going to have x squared minus 4x minus 45 for A. I'm going to have x squared plus 4x minus 45 for B equals 0. Okay, so I could take x plus 5 times x plus 9, and I could put that in y1, and I could put one of my answer choices in y2, and I could go to second graph and see if they're the same. So I could put this in y1, I could put these in y2, I could go to second graph and see if my table looks the same. If it does, I have the right answer. If it doesn't, I don't. But let's go ahead and work this out. And first of all, then did you catch my mistake? I put x plus 5, and this is going to be x minus 9. So I know that I'm going to have minus 45, and I know I'm going to have, let's just see what happens, x plus 5, x minus 9, so I have x squared plus 5x minus 9x minus 45. So when I add those together, I end up with minus 4x. So A is my answer. Okay, I'm going to do the same thing with number 9. I could put these in my calculator, graph them, and see which one comes out looking just like the picture. That's one way to do it. But if I already know my intercepts, and I can say x equals -1, x equals 7, then I have x plus 1 times x minus 7. So I have minus 7 for my last one. I have x squared plus 1x minus 7x minus 7. Combine those together and I have minus 6x. So D is my answer. That didn't take long at all. Probably would have taken me longer on the calculator. That's the way that goes. Okay, so let's take x equals -4/5 and x equals 2. I'm pretty sure one of them forgot to take the opposite sign. And that's probably going to be, Gage is probably wrong. Because let's multiply times 5. I have 5x equals -4 and x minus 2 equals 0. 5x plus 4 equals 0. X minus 2 equals 0. So I'm thinking Colby is correct. I'm just going to go ahead and pick that. I can work it out and see if in fact it's, oh, I can see which one it is. Okay, so we have 5x plus 4, 5x times x minus 2 plus 4 times x minus 2. So I have 5x squared minus 10x plus 4x minus 8. So when I combine those, I end up with minus 6x. So yes, A is incorrect, is in fact the answer. Okay, number 11 has a couple steps. So the first thing I'm going to do is I'm going to find my equation, my quadratic equation. X equals -3, x equals 11, x plus 3 times x minus 11, x plus 3, x minus 11, x squared plus 3x minus 11x minus 33, x squared minus 8x minus 33. Okay, equals 0. So I have that, and then I'm going to use my equation for the line of symmetry. The line of symmetry is negative b over 2a. I'm going to use that formula for that x because that is my x value of my vertex. So b is already negative, so x equals negative negative 8, which is just 8, and it's going to go over 2 times 1. So I have 8 over 2, which is 4. So x equals 4 is my x-coordinate of my vertex. So, interesting things we learned, my zeros or my roots are going to have opposite sign of my factors in my quadratic. And it's really easy to do. Work either way. We can factor and find the zeros, or we can take the zeros and work backwards and find the quadratic. Piece of cake.